Okay, we're going to go through the very basics of Java and the parts that we use the most for the actual robot code. And then at the end, we will demo and look at some of how the actual robot software works. Okay, so this will be kind of, you'll be able to follow along with the Jdoodle links for each of these. We can kind of look at the interface, but basically this allows us to run simple Java programs in the browser, so you don't have to install anything, and we can get right into actually looking at how the software is written and what it allows us to do. But basically the main point is that ideally we're going to be able to have people learn to use Java as a tool to allow us to instruct the robot how to operate on the field, whether that's running the taking the commands from the drivers, moving the joysticks and hitting the buttons on the gamepad and having those translate to actions on the robot, to actually doing the autonomous programming where we're figuring out how the robot's going to navigate and drive on its own, how it aims at the goal or whatever the scoring object is for next year. All sorts of things that go into the software that allow us to tune the different systems and make everything better so that the robot's more efficient and more effective on the field. And ideally is helping us perform better, win more matches, win events, all of that kind of thing. Okay. So if you click the links on the first or on the slide, you can go to the Jdoodle. They pull up the pages already ready to go. Everything should work. I went through it last week, so I think everything's good. And we're just going to talk about what different elements of it are and how they all work. So at the very top, these first two lines that we see, they're in this green color, and in Jdoodle, that means that they are comments. So these are things that the robot pays no attention to at all, or the computer, or whatever you're programming, does not pay attention to your comments. The comments are just for us, the humans, reading the software. Because a lot of times the software itself, the actual program that we're writing, isn't super obvious as to what the intent is or what it's actually trying to do. So it's super important that we comment it so we can use natural language in English to explain what we're trying to do. And therefore, when someone else comes in and tries to modify or use our code, they have an idea of what the intent was. But also, it's commenting is not just for other people. It's super important for yourself, because you may write something one day, have a very nice code, it makes total sense to you, and then a month later you come back and you need to change something on it, and you have no idea how it works, why you did it that way, and you have to go through and try to re-diagnose everything and figure it out. Or if you leave nice comments, you know what is actually happening, and you know why you did things the way you did them. So all of these lines, anything typed after the // is a comment. And these are just single line comments, so these let us comment anything that's on this line, anything that's after these slash marks. The computer and the actual program are just going to ignore, and they're just there for the humans to read. So we see we do them up at the top describing the comments, but we also do it on the lines. So like this comment here is going to start telling you what the actual program, that line of the program, is doing. There's not a second type of comment in this actual code, but there is in this example. So this / is a single line comment. / or / allows us to do multi-line comments. So you can do /*, and then you can hit enter, and you can type whole paragraphs. You can type as much as you want, and then you do */ again, and that lets us end it and tell the computer where our comment ends, and then we can start using. We can start writing normal code again as well. That's something that the computer is actually going to read and interpret as part of our program. Okay, the next part that's useful to start talking about is the idea of variables, and this is really important in software because this is how we tell the computer to store information. And not only does it store it there, it also allows us to pull it back and use it later, which is super important. So variables aren't necessarily just like you use them in math class. They're not like you're just, it's not something that's moving all around all the time. It's not something that's necessarily that you're trying to like solve for. Most of the time, or a lot of the time, it's just giving a name to an information or to a piece of information that allows us to easily refer back to that piece of information without having to know it all the time. So we may not know a specific value, but we can name that specific value, and then we can just use its name anywhere we need to. Or if we need to modify that value, we can use that variable name and then tell the software what the new value is going to be or what the new bit of information is. Because it's not just always numbers. It can be basically any amount of information that we can represent for the program. We can store it in some type of variable. Variables, naming variables is pretty important. A lot of new programmers will just use kind of random things like X and Y when it doesn't make sense to use X and Y, or just letters or whatever names, right? The computer doesn't know what the meaning of the variable name is. They just know what you name it. So you could name every variable Joe or Joe Bug or whatever you want to name them. You can give them human names, but that's not useful. So the variable should be able to identify what the data actually represents whenever possible. So and sometimes if it's actually just doing math, X and Y makes sense. That's what we call variables in math. That's totally fine to do it. But if they're representing number of students, you could literally name it num students or number of students. Like they can be pretty long if you need them to be. It's okay for the variable names they should really describe what you're trying to store there as much as possible. Yeah, so answer is a good example of that. We're storing the answer to the problem, or we're storing the answer to whatever the equation is. And so that's a good variable name here to name it that instead of using Z or something else that doesn't describe what it actually is. So we can see it in our actual program here. We have these variable declarations. That's what these lines here are. They're declaring these variables. So they're basically establishing that these variables exist. And then we're assigning values to them as well. The three variables that we have here have this 3 letters in front of it that actually stands for, we call it an int. It stands for integer. And this basically just tells the software that we're only going to store whole numbers in this variable. So we're going to store counting numbers 0, 1, 2, 3, 4, negative 1, 2, 3, 4, all the way up and down to larger than we need to worry about at the moment. But the critical thing for integers is that they can't store decimal points. So a lot of times when we're doing software, there's going to be times where we need to have a variable and we know it's going to need to store decimal points. There's other times where we're doing specific things that never need to store decimal points, and we can use integers for that. Okay. All of Java, you can see all of these lines, they have these semicolons at the end of them. The semicolons at the end of the line in Java is basically to tell it when the statement is over. So it gives it like a nice unit that it's going to use and interpret as a whole. And so the semicolons allow it to know that int x equals 10 is something that it should interpret as a line of code. We call it a line, but it doesn't actually have to be one line. You could have multiple. So this is the same thing to the software. It doesn't care about the second line there or anything. It's just waiting to find that semicolon to tell it to block all of this stuff as a single statement for it to interpret. If you forget the semicolon, the program will not run correctly, because then it thinks that both of these things are the same statement. So if we delete one of these semicolons, and now we have int xy equals 10, int y equals 20, it doesn't know how to interpret both of these as one thing, right? Because to the program, that's the same thing as doing this, and it doesn't know how to deal with that. When we actually get to compiling and running this, if you start deleting semicolons, you'll see that Java will start giving you errors, and you'll see the error message, and it'll tell you where the error is. So when you actually try to run it, it's pretty smart, so it tries to help you fix your program. So you can see the error here. If we delete the semicolon after 20, it tells us expected a semicolon, didn't see it, so it had an error, and it even points out where it expected the semicolon to be. So then you would just go in, type it, and you could fix the error. Okay, so like one of the fundamental building blocks of like being able to have programs, um, it depends on the type of error. So Carter asked if there's ways for, if it has errors, will it run? Um, there are ways for you to basically anticipate that the program's going to have an error and kind of write code that tells it, hey, look for this error, and if it comes up, do this. And so if you do that, it'll still run. If you don't, and it gets to certain things that are errors, it won't run at all. But there's different types of errors that allow it to do that. So the semicolons, if you don't have them, it won't run at all. It won't be able to do anything because it just knows this is invalid, basically. It's like giving it a set of instructions. If you as a person only took in instructions about how to make cookies, and someone gave you the instructions for how to operate a sledgehammer or like a jackhammer, those are two very different things, and Java doesn't know what to do with it if you don't give it the proper instructions. So you have to make sure when you actually tell it to, we'll talk about what compile means, but basically, or build. And basically, when we tell it to do that, when we tell Java to interpret this thing as a program, it goes through and checks everything, and if it finds places where it can't interpret it as a program, it kind of points those out, and then it expects you to fix them and then try again. Okay, so one of the more important and useful parts of computer software is being able to do math. Like, it's one of the first things we ever did with computers was to be able to do math. And it does it very, very well. And it's very easy to do with computer programming instead of writing it all out or anything. That's right. That's why you use calculators a lot of the time. It's a lot faster. But it is it's slightly different, and there's a few little tweaks to how we do things in programming than how you necessarily do things in math class. So the equal sign in programming is slightly different than it is in math because we use it to mean the assignment operator. So equals doesn't necessarily mean that these two things are the same. It means that we're making the first thing be the value of the second thing. So it tells the program to assign a value to a variable. So whatever's on the left is now going to equal whatever is on the right. So 10 equals x is going to throw an error because it doesn't make sense. Right? 10 is not a variable, 10 is just a number. We can't make 10 equal to whatever x is already equal to, whatever value x has. We can't make 10 equal that. And since we can't do that, that just doesn't interpret right in Java. It just doesn't make sense, and it'll throw an error. However, x equals 10 does make sense because x is a variable name. We can tell x to equal 10. Basic math works the exact same way as you would expect, just like if you're using a calculator, or if you're just like typing math into Google, it does it the exact same way. So you can subtract, multiply, divide. All of those operators work as you'd expect. So the minus sign is a dash like normal, asterisk is multiply, slash is divide. Division is important, and we'll get back to this in a second, but remember, currently what the variables we have only store whole numbers. So if you divide the whole numbers and you try to something that's going to end up with a decimal, it's just going to cut off those decimals and not be able to store them because it only stores the whole number. All of these symbols are called operators, so they have special places, right? You can't make the plus sign be a variable name because it's an operator. Java knows it does a certain thing, and so you can't make it a variable name because it's in charge of adding things together. So they're special characters that are operators that you can't use as variables. In this program, we have 10 being stored into x, 20 being stored into y, and then answer is going to store the solution to x plus y. And once we actually store the answer, we need to be able to do something to tell the program to let us see the answer, right? We've stored it in answer. We've stored that value in the variable answer that's named answer. But now we have to do something to let the program actually see that value. And in this case, we're going to print out the value of answer. And by print, we just mean we're going to display it. We're going to show the value in what's called our terminal or anything like that. It's basically just a text display that allows you to get some output from your program very easily. We often say print. We don't actually mean send it to a printer and put it on paper. We're just going to display it on the screen. The way we do that is by using a what's called a method in Java. Other programming languages often call them functions. And basically, it's just the name of a different instruction set that we can tell the Java program to go and use. So we're writing our own program, but we're using a lot of programs that are already written by a lot of other people. Hundreds and hundreds and hundreds and hundreds of other people have worked on writing an entire programming languages and like the different software that already exists for the robots that we use that we're able to leverage and use to make our robots a lot easier than having to write every single thing that we want it to do in some way that the computer understands. That would be really, really hard. So we have a lot of things in what are called libraries where we can kind of just look and be like, oh, we want the robot to do this. We have a method or a function that allows it to do it, and we can kind of just hook everything together in the right order that we want and kind of make the robot do the things we want to do. That's kind of what we're doing. It gets a lot more complicated than that, but that's roughly the idea. This specific method, system.out.println, the ln here stands for line, so we call it system.out.println. And then you can see it has a parentheses and another parentheses. So they just open and close parentheses. Oftentimes, inside of these parentheses, we will put our variables. So we'll tell a method, we'll give a method some variable to do something with. So instead of just telling it print line blank and letting it print whatever it thinks it should, which is just going to be nothing, we can give it something to actually print by putting it inside those parentheses and telling it what to print. The specific method for print line allows us to give it text. Text in quotation marks is important so that we know that it's not a variable or another method or anything else. So when we put quote marks around things, we're telling Java this is some amount of text that we actually want you to know is just the text itself, right? It's not a variable. We can't store 10 inside quote answer colon space quote because it's not a variable. It is just, as it says, in this case, it's just that text itself. We can store text in a variable, which we'll get to in a little bit, but the text itself is not a variable. In this case, and also in Java, when we are using text, we use the plus sign, very similar to what you would do in math. We basically use it to append the value of answer to the text. So if we want to output the answer, we're going to do plus answer, and Java's going to know to convert answer to its value, and then also convert that value to its text representation. The variables are, so the question was, how does it know not to print out a variable that was like a variable A? And so Java does know that spaces exist. So the variable A with a space after it is different than the variable ANSWER and then a space after that. So if you did put a bunch of spaces in it, Java would be confused. It wouldn't know how to get rid of the white space in between them. Is there a difference between capital A and lowercase a? That is a good question, and I will leave that for just a little bit because in a second you're going to be able to play with this command and you can find out for yourself. Because you can edit it and have it run in just a second. So we'll look at that. Because that's literally the next slide, is to explore the program. So we can change the values of the variables. We can see if we get the results you can expect. We can change the operators, so plus, minus, subtract, multiply. You can change the case and names of all the variables. And we can see how it prints. You can change the different texts, so we can actually see how it works. So we can run the first program here. If we actually hit execute, it should run. And we'll see the Jdoodle is running, and it tells us the answer is 30. So 10 plus 20 is 30. That's what I would expect from our first program. So it's good that it's working correctly. So now we can see if I do what Lester asked, and I capitalize the x here. So now we're going to determine whether x or capital X and lowercase x are different. And I hit execute. We can see what Java gives back to us. Java says, I can't find the symbol lowercase x. The variable lowercase x isn't anywhere that Java can figure out where it is. So then it gives us an error, and it doesn't give us an answer. So that means it does need to be case sensitive, is what we call it. So it cares about whether it's uppercase or lowercase. So if we switch this here to uppercase, we should be back to working again because now our variable is just named uppercase x. Yep, and so we get the answer 30 again, which is what we expect. So we could do similar things, and we can see what happens if you delete other white space, if we don't have space around the operator. That time it's OK, because Java knows that the plus sign is an operator. That's why you can't have a plus sign as a variable. You can't have x plus as a variable. Because, again, those operators are special. So Java kind of treats that as the difference between the variables. It knows it's not capital X plus y is one variable name, because it knows that operator is different. If we change any of the numbers, if we try to make it a decimal, so I said we couldn't have these be decimals, so if I try to make it 10.5, it shouldn't let me. Yep, so it says incompatible types. It basically says you can't assign 10.5 to the integer x because it doesn't hold a it actually has a decimal point, which we can't have here. We only need to have integers, which are whole numbers. We can move things around. We can multiply. We should get a new answer, so now we get 200. 10 times 20 is 200. That sounds right. We can see what happens if we didn't have the extra space after answer, and we have that colon. It's just going to remove the space here, so now it's just colon 200. So all the space goes away. I think that's about most of what we're doing. Yeah, so we change the operator. We can change the text. You can type other things. It should print all that. Anything between the quotes, it's going to print out just as it is. Other things that don't matter. So we can change the order. So if you change lowercase y to capital X now instead of the other way, just like in math, it's going to happen. It's going to give us the same answer. It doesn't need to know which order it is. I'm not sure if I covered this, but I remember covering it last time. It is important that you do things in order. So we can see what happens if I move. So I just cut that with Control X, and I'm going to paste it back with Control V. So if I move this into the middle here, we can see what Java does. So Java is confused now because we're asking it to get this value y, but we haven't actually told it what y is yet. So Java is going down the program in order from the top to the bottom, and it's telling, and that's how we're giving it its instructions. So if we ask it to do something out of order, it doesn't know how to do that. And so if we put it back, it'll work again. But now if we ask it to do something like this should also give us an error because we haven't told it where answer is. So yeah, here, so it doesn't know where answer is. But if we get rid of answer here and we tell it to just print out the text without any of the variables, it should work because Java knows where the text is. We've assigned some other variables. That's all Java cares about is the instructions we've given it. So this is one of those ways where even though we meant for this program to do one thing, because we may have written it wrong, we have a little bit of an error, typo, a little misjudgment in our logic, it's not going to do what we actually intend. So a lot of what we have to do in the software as we're writing code is get it to do what to not only understand exactly what we want the robot to do, or the robot and the program to do, but to actually write it in a way that the robot and program can do what we want. Because at all times, the program is going to do what you told it to do and do that exactly, right? It does not know what your intent is. The intent is what we do in the comments. That is for the humans. The program is going to do what you tell it to do every single time, no matter what. Okay, let me go ahead and reset that. A lot of these like extra lines, for anyone who's done some other programming, Java does not care about indentions. Like I said, like the semicolons and stuff are important, but indentions aren't. So all of this is the same to Java. It doesn't know, but all of that is important for humans because it allows us to read it easier, right? If we have like all of these things over here, we don't know that they're all inside of this thing. This thing is actually a method. This is the main method. That allows Java to know what to run first. And so we tab everything over so that we know where it is in the software. I'm not sure why it's slightly different tabs, but it's fine. Okay, so yeah, so the tabs aren't important. The line breaks and things aren't important either. But again, for the ability for humans to read everything, we want it to look nice. Doing a bunch of things on the same line isn't always what we want. So leaving it here, we have one line for each assignment. Doing our method call is the way we'd prefer to do it. And we'll look at how like the actual robot code looks like in just a little bit, or towards the end. Okay. So the one thing we did not show here is we did not show division. So if I switch this from multiplication to division, we can see what happens. So we expect, well, let me switch it back to x and y, sorry. X, y, back to what we have, so everything looks the same on the slides. Okay, so the variable names are back to x and y. We have 10 and 20, so we're going to do 10 divided by 20. And if we divide that, it's going to give us an answer that doesn't necessarily make sense. It's going to give us 0 because it can only take the whole numbers, right? So it's just completely ignoring the half, the 0.5, and just giving us back the whole number, which is 0. Okay, so if we actually want to have decimals, we have to use a different type of variable. So types are very important in programming because if depending on the type, the value might be the value to answer might be 0.5, or the value to answer might be 0. And so because of that, which type of variable you have determines a lot of how you're actually able to use that variable in your program. So we can change the type here from int to double. Double allows for decimal points to be stored. The question in chat is why wouldn't we just always use doubles? And that's a really good question. At some points, it depends. There's a variety of reasons why you wouldn't always want to use double, or you wouldn't want to always use doubles. sometimes the value you're representing is something that can only be counted in whole numbers, right? If we are literally writing a program that is designed around the number of students in the class, we wouldn't want someone to be able to put in 3.75 students. That would not make any sense, right? That would break the entire intent of our program if they're able to do that. So by making it only integers, we're telling them, no, you have to have counting numbers because you can't have 3/4 of a student. We don't want that. And that happens a lot with how we're representing data. In like the robot context, we have things like we're launching, or we're counting the number of balls that go into the robot. If somehow our program gave us 2.5 balls in the robot, we would not want that. We want it to only count 2 or 3 balls. And we want to make sure all the software that's working with it knows that and doesn't try to put any decimals into it. The other reason, and it just kind of depends on what you're using, is the amount of space it actually takes for the computer to store that value is different. So a double, because it has decimal points, it's literally able to store more information. It takes more of the computer's memory and storage, depending on what you're doing with it. If you're like using a hard drive, potentially takes up more hard drive, but most of the time for programs that are running, they use the computer's memory or RAM. And so if you store everything as doubles, nowadays RAM is cheap and we have lots of it. But even as you get into bigger stuff, especially if you get into more complicated things like artificial intelligence and some of those processing things where you're trying to do math really, really quickly, integers are also faster than doubles. Doubles take longer to compute because the computer just has to do more work to figure out the answer. So if you can solve it using integers, it can run faster, it can take up less memory, it can just be more efficient overall. So depending on what type of data you're using, a lot of times it is better to use integers or other quick and smaller sets of, or smaller variable sizes, basically. Okay, so in the program, if we change all of these places where it says int to double, we can see our answer to our division problem with a little bit more precision, and we can see that it does give us 0.5. If we change this 20 to 21, we can see that it'll give us a much longer decimal, so we can see exactly how it represents. So it gives us this 0.4761 out to quite a ways. And so you can see how many decimal place values that it represents, at least in the print. I don't know off the top of my head how many values it actually represents. I don't remember. But at least when it prints it out, it gives us this many. Do you have to change them all to double for it to work? Let's find out. So if we just change it to double on the answer, so where we're actually going to store the value, it still gives us 0, but it actually tells us that it's 0.0 so that we know it's a double. So it's basically saying this could store information, this could store decimal values, but what we have here doesn't give it to us. So let's see if we were to change just y to double. Now, because we have one of our numbers as a double and the other as an integer, we are able to see that we're getting our decimal point values back. And so the reason for this is the way that Java handles all of its instructions in pretty much any programming language is it looks at the two values it's actually doing the operator on. It doesn't really know where it's going to assign it yet. For a variety of reasons, it doesn't worry about that. So it just sees I have x and y. Both of these are integers. I'm going to make my answer an integer. But in this case, when it sees that it has an integer and a double, then it says, oh, I'm going to use my answer as a double because that has more precision already. And so it does the double thing for us, and it gives us decimal points. How many places does it go to? Yes, but getting 2 pi is a little bit tricky here. I don't actually know. We can see if this will work, because I'm willing to look at questions real fast. should be something like this. We'll see what the error is. Should be able to get pi. There we go. Okay, so math is basically, we'll get into this in a little bit later when we start talking about classes, but math is one way we're basically telling it to look in the math section of its information, and we're wanting to retrieve the value pi from the math section. And you can see that it gives us, it prints out this many decimal points. Again, I don't remember off the top of my head how much it actually stores precisely. It might be a different number than what it actually shows us. Those two things don't necessarily the same. But it can do, you can get things like pi very quickly. You can do all sorts of trigonometry, geometry problems, all sorts of things. There are different like math libraries built up to do really advanced math. Pretty much all like super advanced math and things anyway are done by computers and programs like this at some level. Okay. Back to answer as we move on. Okay, so we talked about how text inside of quotes is used by Java to know that we mean the text itself and not a variable. What we call those is a string. The reason we call it a string is it's a string of characters put together, right? So it knows that A is a character, NSWER, and it counts all those as characters. And inside of quotes, we have a string of characters, and we shorten string of characters down to string. That's how I think of it. I'm pretty sure that's right historically, but it's useful to think of it that way, even if it's not completely correct. And then we can use this string in future methods and other times that we need to use it or modify it potentially in the future. So we could go and make it a string, the string text. So the name of this string variable is going to be text, and it's going to be equal to answer colon space. And then if we change this here to text, we can use that variable. Except I made a typo, so I didn't put the semicolon here. So if we were to run this, we'd get that same error that we talked about before. Java's like, hey, I expect a semicolon. It tells us. And then we go ahead and put it in, and then we can see what our execution is, and hopefully it should be the same. Because all we did was kind of move how we represent this information, right? This is the exact same thing as we had before to the software. It just has to evaluate it in like one extra step. So it has to come here and say, what is text? And it looks up here, sees it, puts it in, and sends it over to that print line method for us. Most of the time, that one extra step doesn't affect any of our speeds. Like it's doing stuff so fast by most of the processors and things that we're running, the computers that run our software, that extra steps like that aren't very often a big deal. But they potentially can be, especially if you're running on very slow computers like microcontrollers and things that don't have nearly as much processing power as like a PC or even a robot. Sometimes things like that do matter. Most of the time, not anymore, especially not with Java, but that's for later. Okay, so that's most of what we're going to show in the first program. So we're going to go ahead and open something a little bit more complicated. So we're going to go to the second program. So if you have the slideshow open, you can go ahead and click this link. Should bring everything up, and it does. All right. So we're going to start looking at how Java represents some logic, basically. So how we can look at what are called Booleans and determining if things are true or false. So when we run this program, we get this output. So we get B1, and we'll go through all these in just a second, but I can describe what tell you how they read to us as you start learning how to program, is B1 and B2 is false. So at the beginning we told us that B1 was true and B2 is false. And now we have B1 or B2, and the answer to that is true. Because B1 is true, therefore B1 or B2 is true, so we get true back. We have not B1, so we basically get the opposite of B1, or we invert B1. And since B1 was true, we get false. And then we can also do some comparators to our actual variables. And so we can compare, just like in math, greater than, less than, and equal to, and we can see those answers too. So we can get true, false, and false. So x is less than y, x is not greater than y, and x does not equal y. And we can look at why all of those exist here in just a second. So if we change some things in this program, so you can go ahead and explore the program, you can change B1 and B2, you can change the values in x and y. Yes, there is a greater than or equal to. It's rather simple. You can just put the equal sign right after it. And now you get greater than, or you get less than and equal to, and greater than or equal to. So sometimes it is very important whether you want to include the equal to or not. And it just kind of depends on the software that and what you're running and what you're trying to do. So if we change this to true, we can see the output here now is different. We get B1 and B2 is true, because they're both true, so then that means they're true now. B1 or B2 is still true, because either of them is true, that means they're true. We didn't change B1 at all, so not B1 is still false, and we didn't change any of those bottom ones either. The different values for x and y should let us see different things. So if we change it to x equals 20 and y equals 20, and we left them as less than and greater than, we get false, false, true. And if we do, like we just talked about, we can do less than or equal to or greater than or equal to, we should get all trues at the bottom down there. Maybe not. What is, why? Now I'm confused why we don't get. Oh, because I only changed the, this is a typo on my fault. I only changed what is actually printing, right? So the stuff inside the quotes is just for our display, so it's changing this section. It doesn't actually change whether it's false or true. That happens over here. So that was actually a complete mistake on mine. That was an honest mistake. I actually didn't catch it. That one was not on purpose. So we have to put the equal signs over here as well. And now when we execute, we'll actually see that they're all true. So we need to change in like our display telling us what we're doing, and in our actual, and what the program's actually computing for us. So it's converting this statement right here and evaluating whether it is true or false. So it's basically deciding, is x less than or equal to y, and replacing that with the value true or false. We call those values Booleans. So that's a type of variable that we can have. So similar to ints or doubles, we can have Booleans. Booleans can only have two values. They can only be true or false. You can't assign anything else to them. You can't assign 0. You can't assign maybe. You can only have true or false. Boolean logic is pretty much the foundation of how computer programs work. To actually build computers, you have to use things called logic gates at the very, very small level, like inside of the processors and things. There are a lot of these things called logic gates that are basically doing this logic over and over again and allowing our different circuits and computers and things to work in different ways. That is rather important to the whole idea of computers and software existing at all. This is also very important to logic in like the philosophical sense. So if you ever take a logic class, like the philosophy class logic, this is kind of the base for that as well. It is important that they are lowercase. You can't have capital T true. capital T true does not mean the same thing. Capital T true can be a variable if you want. Don't, because that's super weird and would be very easy to misunderstand what was happening. So we shouldn't just name a variable true, but you could, because it's not a keyword. So you see it, like in this case, a lot of times the compilers will have things change color for a reason. So the black text is something that could be a something that we can assign a name to. So it could be a variable, it could be a method or something like that, but it's not a operator or a keyword or anything that it's going to know exactly what the definition of is. The definition of is already. So we need to make sure that's back to lowercase true, because if we try to execute this, it's going to give us an error because it doesn't know. It knows that Boolean values can only be true or false, can't be anything else, and they have to be lowercase. Okay, so the logic operators that work on our Boolean values, we already kind of went over them, are AND, which is the double ampersand symbols, shift 7, OR, which is the double pipe, which is shift the slash key, the one above enter, and then NOT is our exclamation point. And so those operators allow us to do a lot of things on these Boolean variables that come in very, very handy as we're going through software, because we can do things like checking if one sensor or another sensor are blocked or active or something like that on the robot, right? So we can say only do this certain thing when both the A and B buttons are pressed, and we can use Boolean logic to do those, or A and not B or something like that, right? You can combine them in lots of ways to get the robot to do exactly what you want. We use it a ton on the gamepad for different button combinations and things when we have to hit one of the right shoulder buttons and the D-pad to like reorient the swarm drive. That's what it's doing, is it's evaluating those two different things that result in a Boolean, whether they're true or false, whether the button is pressed or not. And then we combine them to get the output that we actually care about. Okay, so the lower section here, we have operators that are comparison operators. So these compare two values, and then based on the results, return a Boolean. So they give us true or false. When a method, remember methods are like functions, when they complete, they call it that it returns something, because it basically allows the software to kind of replace that statement with the new thing. So equals is different than the double equal sign, is very different from the single equal sign we're using before, right? Because we talked about the single equals in programming is the assignment operator, so that means x equals 10. The double equals is our equals comparison, where we're basically saying, do these things equal each other or not? If they do, we return true. If they don't, we return false. You can use the not on the equal, so you can say, do these things not equal each other? And then that just flips how you get your true and false. And then we have greater than, less than, greater than or equals to, less than or equals to. But one of the biggest things to take away is the difference between single equals and double equals. Those are very, very different things, and they have to be used in their correct places, or you get very different results. So we can see something like this. If we were to change, if we made this a double equal sign instead of a single equal sign, and we tried to execute, it doesn't know how to do that. It's like string text, and now you're asking if it's equal, if it is the same as answer, without actually giving it a value or telling it what it is, and it doesn't even understand how to work with this statement, because it's not the assignment operator, it's a different operator to Java. Okay, so we can go a little bit further, and we can go into our third program. So our third intro Java program lets us combine several of things that we've already looked at. So we have some Booleans, B1 and B2. We have some integers, x and y. And now we're going to start looking at some ways that we can control the flow of the program and have it do different things based on different values, states, anything like that. And the first thing we're going to look at is if else, and and else if. We're going to look at if, else, and else if. There we go. I can say it in the right order. So when we run this program, we're going to see 3 outputs. So we only see 3 lines printed here, even though there are 6 different print line statements in our actual program, right? So we have 1, 2, 3, 4, 5, 6, but the program actually only printed 3 times. So if we start exploring this program, and you can go ahead and do it on your own, and you can change anything you want and execute as you go through to see how it actually works, we can start seeing what it actually prints and how it works. So the very first statement we have is this: if B1, print out B1 is true. So if we change B1 to false, and we try to print, we can see if it still prints out B1 is true. So when we execute, it doesn't print out B1 is true at all. It just skips right over it. Because B1 is false, this if B1 line, everything inside of it, the computer just completely goes past because it's not true. So this is basically telling the computer only do the things inside these curly braces if B1 is true. And this is probably one of the most fundamental parts of how we do all of our programming on the robot, and pretty much how software exists at all, is being able to have these conditional statements that say if one thing is this way, or if it's this way, do different things. Okay, so we can combine those a little bit. So we can have if B1 and B2. We can check if that is true, and if they're, we'll print out that they are true. If it is true, if B1 and B2 are both true, we'll print out that it is true. However, if it's anything else, if it's not true, it will print out that it's false. Not equal to, we looked at just a little bit ago. Not equals, remember the not operator is the exclamation point. So not equals is exclamation point equals, not equals. Okay, so let's see. So B1 is true, but B2 is false. So down here we are printing out B1 and B2 is false. So that's basically, it's going into the else because it's getting a false here. We have an else command, so then anything else that happens, no matter what this is, as long as this returns not true, it's going to print out this statement. So if we make this, if we make B2 true, we should be able to get it to print out that it is true. Since they both are true, therefore B1 and B2 is true, and we see that statement down here. And then we can go a little bit further when we have more than just Booleans that we're comparing. Since we have, or even if we are comparing Booleans, we could still do things like this too, because we have different things based on different ways to compare them. So, but with integers here on our third one, if they're actually equal, it'll tell us x equals y. If then it checks again, so it's basically like going through and checking things. So it's saying, does x equal y? If it does, go ahead and tell us that. Then it's going to come down again and check, is x greater than y? If it does, it's going to tell us that. And then because we know the only way to get to this final else is for x and y to not be equal to each other, and for x not to be greater than y. So we know just based on math, right? There's no other option except for x to be less than y. So when we execute that, every time we've done it, we've seen so far that x is less than y. So it's going through each of these 2 checks and then getting down to our else statement and printing that out. So if we change it, if we make them equal to each other, we should see that it tells us that x equals y. And if we go the other way, we should see that x is greater than y as well. And so it's always going to execute whichever line meets the, actually is whatever one right after the if is true. And then if none of them are true, it'll execute the else. Just like up here, you don't have to have an else. So if we were to get rid of this part, and we went back to our x less than y, it just won't do anything, because it basically says, if x is equal, do this. If x is greater, do this. And then what would be your else is just nothing. Okay. So yeah, just recapping real fast. So if statements let us control the flow of the program, lets us do different things based on different comparison checks, basically based on different variables. We give the if a Boolean somehow to tell it whether something is true or false. It checks that conditional, and if it is true, it runs the software inside of it. If it's not, it skips over it. Else lets us do things. Yeah, and then else basically lets us do things if the conditional is false. All right, so we can move on to our fourth program. Okay. Okay, so the fourth program, when it executes, we actually are getting a little bit more complicated. So we have our own methods now. So before we had been doing everything inside of that main method. So all of these just had that main method and they were just running. We've now written these two methods up here that are specific instructions for the program, just like main is, except we can reuse these inside of main multiple times. So it can allow us to have much more concise and easy to understand code, because we're able to reuse these methods whenever we need to. So we can see what this program does. It has the same variables that we had before, and instead of having those if statements, we have a few things in here. So we have a system.out print line. So we're going to tell it to print something, and we're going to tell it to print add for method, and we're going to pass that, or we're going to pass x to that method. So we know x is 10. So the computer, while it's going through and actually reading this, when it's executing this line, it's going to substitute x for 10 because we have that value, because we know x has a value of 10. And then it's going to run the add for method. So we're going to come up and basically, the computer's basically going to come up here. It's going to see that add for has another, I'm trying to think of the best way to describe this without getting too complicated. We call them arguments, which is like a weird word for it, but that's the name that we use in software. But in reality, it's just like a variable for the add for method that we describe the same way that we describe the other variables. So it's just double num, so it's short for number. And so we're putting 10 into num, and then we're going to execute the code that's inside of this method. So we're going to return num plus 4. So return basically tells the program, what do we give back? How do we, or what, give back's a weird way to phrase it. What do we push back up to where we were, where we came from? This double right here tells it what type of method we're gonna, or what type of variable we're gonna return. So this add for, we put in 10, 10 goes here into num. The computer does 10 plus 4, gives us 14. We return 14 as a double to the print line method. It then sends the value 14 to print line, and we see that it printed 14 out down here. We can see that it was a double because it has the 0.0 there. Again, types matter a lot. So if we end up having something, if we could change it, we could change it to an int. So if we change the return type to an int now. Oh, actually, it doesn't let us do that for a reason that I'm not going to go into. Doesn't let us do this. This one I probably should have checked ahead of time. No, okay. There's a reason why it won't let us do that. It doesn't, because it could potentially have a decimal point because it was already stored as a double. It doesn't like that. That's a little bit more advanced than I want to get into, so I'll leave that alone for now as to why that throws errors and why it can't just do that math. Coming back to the program, we can see what happens in our next method, which is if true print. So we wrote a method that basically says if whatever we pass in as this Boolean is true, then we're going to print whatever number that we send the method as well. So methods can have more than one argument. So in this case, it has a Boolean bool, and then it also has a double num. And then this method also doesn't return anything. So up here we had to like send a double back. This method has a return type of void. And void just means it doesn't ever return anything. So you can't just like put this method inside of another method and have it do something that way. It doesn't come back with any sort of value or anything. This method just does something. So in this case, it checks if bool is true or not. If it is, it then prints out num. If it's not true, it does nothing. So since b is true here, and we have if true print b1x, we can see that it prints x, so it prints that 10 there. Because b1 was true, x gets printed out by this method. And since not b1 is false, y doesn't get printed out. So if we change b1 to false, it should flip that around and it should actually print out y instead of x. And we can see it does. It prints out 20, which is the value we gave y, because not b1 is now true, because not false is true. So we get 20 out of it. Okay, so a couple things when we actually make a method. The beginning here says public static. For right now, just know they help make the program work. They're important. We'll talk about, you'll learn more about them later as we figure out what those kind of mean. But they basically are just declarations to let the program do what we need it to do, and for main to be able to know where the program is and use it, to use each of those methods and everything like that. The next value here is the return type. So it always basically says what's the equation. So you can almost always kind of look at it like this. There's like a hidden equal sign here as the equation. So it's almost saying like this double is going to be what comes out of add for double num. Void is used when the method doesn't send any data back, right? So it's just there when the method is going to do something on its own. It doesn't need to send anything back. And a method could return any type. So you can return a Boolean, you could return a string, you could return an integer. Anything could be returned from a method. Okay, so parameters is the better word. That's the word couldn't think of. So the parameters are what we're taking in to the method and what we're actually going to be able to act on and do things with. The add for method has one parameter. It's just num. These are basically the variables that we give it to make it work. One of the things we can do is add for, since we give it x here, but we don't actually have to give it x, just like we did earlier. We can pass variables values directly. You don't have to give them, or you can pass methods values directly. You don't have to give them variables. So we could give it 30, and when we execute that, we should get 34 here because it added 4 to the value of 30. It didn't need to be a variable. Okay. And then return, like we already said, is the keyword to tell the program what data you should send back. And if the method returns void, you don't ever have a return anywhere in your method because it doesn't return anything. All right, we're going to look up at our fifth and final program. Pretty close on time. All right. So this program is getting us a little bit closer to what we'll actually do on the robot. So this is very much fictional. This isn't what the actual robot code looks like exactly, but it's giving us something a little bit closer. And the big jump and the big takeaway here is that we can create what are called classes. So we have this class here, and it's called motor. And classes are allowed to have, it's basically just a way for us to store even more information than what we can store in just a single variable. So a class can have its own variables, so it can have things like channel and speed, but it can also have methods that can be run from that class. So the class has a lot of information, has multiple variables in it, and it has things that we can do to those variables or to the class itself, different actions they can perform. And so that's how we're able to represent a lot of information and how we kind of group it all together in the program and make it all make sense. So when we run this program that's going to have two different motors, we're going to get their channels, and then we're going to actually get their output speeds after we set their speeds. And so if we run this program, we can see that we get M1 is on channel 0, M2 is on channel 1, and then M1 speed is 1.0, and M2 speed is negative 1.0. That's all things that we set up here, right? We basically just type that 0 and 1, and that 1 and negative 1. Okay, so if we change any of those variable values, we can see that they change as well. So if we change this to like 0, when we set the speed, we should see that M1 is 0 when we print it out, which we do. And then we can start looking at how the class actually works. So the class motor has the variables channel and speed, and then it has these different methods, one of which looks a little bit different because it doesn't have anything in front of it. So we talked about methods before always having some return type, right? Either int, double, Boolean, or if it doesn't return something, it's void. This motor method here doesn't have anything, but the program is still working. And that's really important because that's called the constructor, and that's how we basically tell the program how to make this class, how to make an instance of this class that we need. A lot of times they're called objects. So the instance of a class, so this one motor that we're creating is called an object. And we do that by using the new keyword. So in this program up here where it says motor M1, so the variable type is now motor. So this M1 variable is going to be a motor. That's kind of what we say in Java is M1 is, it's how we reference the motor. It's how we would do anything with it. So in our actual robot program, we'll have motor variables, and we can set their speed. We can get information back from them. Anything like that based on whatever methods and values they have in their class. Each object is a new instance of class, so they keep their own values, right? So when we make the new motor 0, it's different than new motor 1 when we have that new tag. So then we can change speed to be different. So when we set speed on M1, it's changing a different variable than the speed that's down here, right? This isn't just a single variable speed like we had before in our main class. This variable gets basically created twice. So now we have a M1.speed and an M2.speed, and they're completely different, and the program knows to store them in different places, and knows that when we ask for them, we're going to have to tell it whether we want the one that's in the object M1 or the one that's in the object M2. The object.method pattern is how we actually call the methods to allow us to act on a lot of this information. So that's why we do M1.setSpeed and m2.setSpeed, similar to m1.getChannel and m2.getChannel, m1.getSpeed. So it actually knows that they have these methods, and it's going to let it know which channel to actually return, which speed to actually return, which speed to actually set when we assign s to speed, which one to do it with. That's all because we have the object first, then the method. Okay, I think I've kind of jumped this gun a little bit here. So yeah, each class gets a unique name. So in this case, the class is motor. The classes contain variables, and this first method here that doesn't have a return type is the constructor. It's what lets the program know how to make an instance of the class, so that's why it's called the constructor. It's kind of building out what the class is and that like instance of the class, that object. And so that's what's called every time we have new then motor question marks. That new command, that new keyword is used to let Java know that we're looking to construct a new class or a new instance of a class. The class has all its own methods. In Java, a lot of times we don't directly use the values that are inside the method. Instead, we do like we do in these examples here, where we have getter methods. So this getChannel and getSpeed are getters because they get values from the stored information in the class. And then we have setter methods, which are methods that allow us to set values in the class. A lot of the classes are going to have way more complicated methods. As we get into more complicated robot tasks, they get much more complicated. But a lot of times these set and get methods or these ideas are very similar. And you'll end up writing a decent number of them for different things that we do in the robot. Okay, so that last slide was something I was working on but didn't quite work in Jdoodle, so we're not going to do it that way. So that's mostly what I wanted to get through today. If anyone has to go, we're right at 9:15, so feel free. But I'm happy to answer some questions. And I'm also going to pull up what we're going to be able to start working on towards the end of October, because we have a bunch of stuff going on over the next 3 weeks, and I'm out of the country for a little while. So we're not going to jump right into it, but we can start. If you want to get ahead, there's a lot of different things you can start looking at and learning. I pulled up the wrong one. Let me pull up the correct one. Maybe this one. All right. Okay, so before I jump into this too much, does anyone have any questions about what we went over tonight in terms of the kind of the basic Java stuff? Jdoodle's pretty cool. You can try different things inside of there. Okay. So let me get rid of, I was doing other things. Okay, let me pull this up to where it makes sense. But so this program right here that you're seeing on your screen is called VS Code, and this is the editor that we use to edit our robot program. And the robot program is made up of lots of different files. It's not just one big file or anything like that, because there's a lot of stuff that goes into it, and it does a lot of things. I'm not going to go into how all these files work right now. That's going to be for a later time. But I do want to kind of show what we're going to be able to do with learning how the robot works. So over the last 2-3 years, they've gotten a lot better at being able to simulate the robot. So this is robot code that can actually run on a robot if we wanted to, or something similar to this. But we can also run simulated on our computer. So we can tell it to simulate robot code, and it's going to pull up a simulation screen that is running the same software and running like the exact same way that it actually runs on the robot. And there's a lot that we can do inside of here. Let me move some things around to make this a little bit more clear what's happening, because there's a lot of windows. And so some of the basic things we're able to do is we have, let me change the view real fast. I meant to do that earlier, so it's a little bit easier to see on your screens. There we go, make everything bigger. All right. So we have a few different things. So we have some joysticks, so it can tell us where we have joysticks. So down here, we can assign the joysticks port values the same way we do on the actual robot in the driver station. So if you plug in an actual gamepad to your computer when you're running the simulator, you can interact with it the same way you interact with the real robot. You can also, there's some virtual gamepads that are made using the keyboard. So I have a keyboard joystick set up over here. So if I use WASD, I can move around these axis values just as if I was moving the gamepad joysticks themselves. So then I can work through the robot program and see how it all works. We have the same modes that we have on the real robot. So we have disabled, autonomous, teleop, and test. And so inside of the simulator, it's actually going through and it's attempting to simulate a lot of what the robot motors and things will do based on the inputs or based on the mode it's in or anything like that. So if I switch it into teleop mode, I have it set up so that X is I think it's the B button, so it's the second button down here. So when I press X, it's going to set up to where it's going to run the intake, and the intake is set up to be our motor number 20. So over here on the right, we see motor number 20. We see that it has like a velocity here. There's a number here for velocity. So when I hit X, it's going to start changing its velocity. And so I know that intake is running whenever I'm holding X. And as soon as I release X, it goes back down to 0 because now we're telling the intake not to run anymore. So it's actually simulating all those values. Same up here, it has the percent output. So you can see what I'm basically telling it to go to 100%. So it's 1.0. So it's going to 100% whenever I'm holding X. Then when I release it, it goes to 0. So that's like the simplest thing you can do, but you can see that there's a little bit more. So we have like this rapid react field diagram here. Down in this bottom corner, we have a little purple triangle. It's going to be there in just a second. So if I use WASD, I can actually drive the robot around a little bit. So if I move it with W, you can see it start driving. I can steer it, and we can actually see the encoders and things that are on this robot moving around. Where'd the window go? So this PWM outputs here, these show the motors. So PWM 0 and 1. And when I hit W, it shows that they're going full speed. So that's full speed on this little robot that we have simulated here. I can go backwards, left, right, and it has all of it's basically figuring out or approximating where it thinks it would be in space if this robot actually existed. Couple other things we have, so we're going to set up and be able to go through is we can simulate some other tasks, not just driving around or just seeing the motor output. We can actually see certain things like an elevator simulation. The graphics aren't very good, but we can get the idea. So when I press Z, it's basically telling the elevator to go to a certain height. So it goes up to that certain height, and it's bouncing around a lot because we don't actually, one of the things we're going to use this for is to be able to do what's called tuning, where we can tell it to like stay at that certain height and be really steady and stay there. And none of that has been done yet, so it's bouncing around. And then when I release Z, gravity pulls it back down to 0 because it's actually simulating gravity and everything. That's the idea. We also have these addressable LEDs that we can play with and do different animations on right now. They're just blinking, but these would be similar to actually putting LEDs on the robot and having it blink or do any animation, so you can actually test a bunch of different LED code in the simulator. And then the final thing we'll be able to look at is doing our autonomous mode. So I think the one that's set up right now is very basic, but it's going to bring the robot back to its like starting point down here, and it's just going to drive forward for a short amount. So if I turn it to autonomous mode, it's going to show it that it's driving across that line and actually tells it like the path that it's trying to follow. And then it just drives that line, and that's it. But you can go through and you can test a bunch of different autonomous modes. We can go through and how we actually do the paths on a real robot. And we can do a lot of it in the simulator, so we can learn how to do it all before we're doing it on the robots, which get a little bit more complicated because there's a lot more potential for errors and things, put holes in the walls, takes more time to change and test things just because it's harder to do on the actual competition robots. It's much easier to do a lot of this stuff on the simulator. Okay, so that's what I wanted to show, and we'll be able to do quite a bit of this. In a little while, we'll go through and walk through, but last things, if you have not, I posted in controls a couple days ago and I'll repost, but over the next couple weeks, everybody should make a GitHub account and make sure to go through the process of getting it set up as a student account because you get some special features, one of which is GitHub Copilot, which is super awesome. It's an AI generated like autocomplete that makes it so you don't have to actually physically type at nearly as much code. You'll start typing, it'll kind of show you what it thinks you want, and you can basically just like tab over, kind of like it happens in Gmail, where Gmail like suggests answers to emails, except it's really, really smart, and it does a lot of it. A lot of times it gets the right answer for you. So you can just you can basically write code a lot quicker because it just does a lot of autocomplete. It's not always correct. Sometimes it's way wrong, and it makes big errors, and you have to go check them. But a lot of times it's right, and you can kind of see what it shows you, like the little gray text, and when you hit tab, it goes through and gives it the right answer, or gives you the answer that you want. It is very, very helpful. Okay. Any other questions before we're done for the night?